In question number 4, basically a horizontal cylindrical vessel is given. This is horizontal cylindrical vessel. Its length is given as 2L. A piston is given, which this is a piston. It is divided this vessel into two equal parts. Like if it's actually it is given 2L, therefore both of the part have length L. Now this vessel is filled with ideal monoatomic gas, where number of moles will be n, and at temperature, and it is filled at temperature T. Initial temperature will be T. This is initial condition. Now it is given, and there are two springs which are attached to the piston and having a spring constant or rigidity K. Now amount of heat, this amount of heat is supplied to its right part. Therefore piston, as the heat is supplied, therefore gas will expand and temperature will raise, and therefore this will provide a force. This expansion of gas exert a force on this piston, due to which the piston move to the left part by the distance L by 2. Now we have to calculate the amount of heat given by the left part to maintain the temperature. Actually, when the compression of gas will be there in left part, therefore temperature will try to increase. Now in order to maintain the temperature, the Q dash amount of heat will be given to thermostat. Actually thermostat, it's a device which maintain the temperature. Therefore basically we can say that in the left part there will be a isothermal processes going on. Now what I am trying to say, that in initial condition piston is in the middle of the vessel, and there will be n mole of monoatomic gas at temperature T. Therefore pressure in both of the side of the piston, left and right side, will be equal to P naught, and volume is also equal. Therefore let pressure in both sides will be P naught, and volume is also equal. Therefore pressure in left or the right side can be calculated by PV is equal to nRT. Therefore nRT over V naught, or V is equal to area into length L. Therefore first part will be there. Now in condition 2, or in second condition second, actually we supply amount of heat Q to the right part of the, assume the piston is there, and we supply amount of heat Q there. Therefore molecule or gas will expand and temperature will raise to T2, and gas will apply a force on the piston which will move to a distance x by 2, sorry L by 2, and there are also two springs of constant K Now spring is at rest, it is given that they are uncompressed, but as the piston move towards left side, the spring in the left side will compress, while on right side will expand. Now molecule remain n, but temperature raises to T2, and assume that temperature inside this one will be T1. But in ordered, as we know that this is isothermal process, therefore it will become T1 by releasing a amount of heat Q dash. Therefore pressure in left part will be P1 is equal to nRT over V1, because area remains same but length will decrease of left one and length of the right part will increase. So therefore volume V1, there in left part there will be volume V1, and in right part there will be volume V2. Therefore P1 is equal to nRT, this is area, and length will equal to L by 2. Therefore it is equal to 2P0 when we compare with first equation. Second, now amount of heat release, let now the amount of heat released from left part in order to maintain the temperature will be Q dash, and our objective is to find Q dash. Therefore in order to find Q dash we apply first law of thermodynamics, applying first law of thermodynamics. Therefore Q dash is equal to internal energy plus work done by the gases. This is internal energy, this is work done by gases or work done by gas. As we know that temperature remain constant or T1 is equal to 2 because of isothermal process, therefore internal energy is equal to 0. Therefore Q dash equal to W1 is equal to equation third. Now as gas get compressed in left part, therefore work done is also negative, or we can say that both of Q dash as well as W1 is negative. Now we know that work done in left part by the gas is related is related to work done in right part plus potential energy or and potential energy of spring. Therefore potential energy of the spring we can calculate from potential energy of the left part plus potential energy in the right part. Therefore potential energy in left part plus potential energy of spring in right part. As spring is compressed by L by 2, therefore half K into L by 2 and expand by L by 2, therefore difference is only L by 2. Net potential energy net therefore this will be 1 by 4 K L square. This is equal to fourth condition. Now potential energy, how this is relation? Potential energy of the spring is equal to work done by the, or we say that net potential energy spring is equal to net work done by gases or gas. This means W2 minus W1 is equal to half K into L square. This is equation 5th. Actually now we our objective, we know that there W2 minus W1 is equal to half, okay, just going on the previous page, 1 by 4 KL square okay, there is one more mistake. One by 4 K L square. Therefore now we have to calculate work done by the gas in right part. Therefore actually we cannot calculate from any of the process or directly calculate work done, because it is not an adiabatic process, because it is not given, plus it is not an isobaric temperature because pressure is changing, and not is isochloric temperature because volume is changing, and neither isothermal because temperature is changing. Therefore work done, in order to calculate the work done, we will apply first law of thermodynamics. Law of thermodynamics. Thermodynamics. Therefore Q, we know that Q is given is internal energy plus work done by the gases. Now okay, fifth. Equation fifth. This is equation sixth. Now we know that internal energy del U can be calculated from NCV del T. As it is monoatomic gas, therefore N is equal to 3 by 2 R, because monoatomic gas. Therefore we say that internal energy del U is equal to 3 by 2 N R del T. Therefore this is equation 7th, or we can also write that is equal to 3 by 2 N R. This is T2 minus T1, or T1 equal to T2 minus T1. So equation 7th. Now at angle, at length L by 2, if this is stopped, then it means that it is in equilibrium. Therefore force due to applied by gas is equal to force 2 is equal to P2 cross A. There will be force F1 is P1 A. Spring is constant. Force due to spring is K L by 2, and there is also K L by 2. Therefore in equilibrium there is expansion, not compression. So this is like this. Now we can just see. Therefore P2A is equal to P1A plus K L by 2 plus K L by 2. Therefore P2A is equal to P1A plus KL. Next, therefore P2 is equal to P1 is equal to plus KL by A. This is equation previous 7th, 8th. This is equation 8th. Now final temperature on right chamber will be, now final temperature at right chamber will be P2 V2 P2 V2 is equal to nR T2. Therefore T2 is equal to P2 V2 over nR. Now this is ninth, putting equation 8th into equation 9th, we get, or just I am trying to say that we will take out the value of P2 and put here. Therefore T2 is equal to P1 plus KL by A into V2 over nR. Now V2 will be equal to KL by A area into 3L by 2 into nR. And we know that from equation 1 that P1 is equal to twice P0 from equation first. Therefore T2 is equal to twice P0 plus KL by A is equal to 3 by 2 AL upon nR. Now temperature T2 is equal to P0 into 3, just expanding the term, over nR plus KL by A into 3 by 2 A by L over nR. A get cancelled. Therefore T2 is equal to 3 P0 into AL by nR plus 3 by 2 KL square over nR. And we know that this is equal to PV is equal to nRT, this is equal to T. Therefore T2 is equal to 3T plus 3 by 2 KL square over nR, as P0 V is equal to nRT. Now this is equal to, if we say previous 8th, 7th, 8th, 9th, this is equal to 10th. Now putting equation 10th into equation previous, okay, equation, this one, 7th, 3/2 nr del t, 3/2 nr t2 minus t. Therefore this is t2 minus t. Now I am placing the value of t2, 3/2 nr, t2 previous 3t, 3t plus 3/2 kl square over nr, kl square over nr minus t. Therefore del u is equal to 3/2 nr 2t plus 3/2 k l square over nr. Now let this equation be equation 11th. Now putting equation 11th into equation previous this equation 6. Q plus equal to 3/2 nr 2t plus 3/2 kl square over nr plus w2. So w2 can be calculated as w2q minus 3/2 nr 2t plus 3/2 kl square over nr. Let this be equation 12th. Now we know that w2 minus w1 is equal to 1/4 kl square. Therefore just putting w2 here, therefore value of w1 will be w1 is equal to q1. Therefore just w2 minus 1/4 kl square W1 is equal to Q minus just I am putting previous value 3 by 2 nr, so 18 minus 3 by 2 minus 3 nrt. Okay, previous, next, and okay, so it says 3 nrt minus 9 by 4 k l square minus k l square by 4. Therefore W1 is equal to Q minus 3 nRT minus 10 by 4 is equal to 5 by 2 k l square, and this is equal to Q dash. Therefore this is our answer, or this is amount of heat released by the piston. Thanks a lot.